We can use contingency tables to solve a number of problems in probability. We'll look at how to use them to solve problems in conditional probability. To do that, we'll need an event we're conditioning on. For example, suppose 58% of vehicle owners own a truck and 68% own more than one vehicle. Of those who own more than one vehicle, 57% own a truck. Let's find the probability a person owns exactly one vehicle that is not a truck. Our events are that a person owns a truck, we'll call that T, and that they own more than one vehicle, V. Now, the conditional probability we're given is that we know that the person owns more than one vehicle, and so the thing we don't know is whether they own a truck, and we're given that probability, T given V, as 57% or 0.57. Now, since we're given the whole number percentages, it's convenient to assume a sample of size 100 times 100, that's 10,000. And it's convenient to let the conditioning event correspond to the row labels. So we'll set up a contingency table using 10,000 owners. Our row labels will be whether they own more than one vehicle or not, and the column labels will be whether they own a truck or not. Now, since 58% of the vehicle owners own a truck, this means that 58% of our 10,000, or 5,800, own trucks. And this is the unconditioned number of people who own trucks, so this amount will be in the total row. The remaining 4,200 people don't own trucks. Again, 68% of vehicle owners own more than one vehicle, and so that means 6,800 of them will own more than one vehicle. And the remaining 3,200 do not. And again, these are the unconditioned numbers, so they also appear in the totals column. Now, we are given a conditional probability that of those who own more than one vehicle, 57% own a truck. And so that's 57% of the 6,800 who own more than one vehicle, and the remaining do not own a truck. Now we can actually fill out the rest of the contingency table, since there are a total of 5,800 who own trucks, and we've identified that 3,876 own more than one vehicle. That means the remaining 1,924 do not own more than one vehicle. And likewise, since there are 3,200 people who do not own more than one vehicle, and we found that 1,924 of them do own trucks, then the remaining 1,276 do not own trucks. So we do want to find the probability that a person owns exactly one vehicle that is not a truck. And we see that there's 1,276 people in this category. And notice that we are not looking for a conditional probability. So it's 1,276 out of our 10,000, or 0.1276. Now, when do we have a conditional probability without being given a conditional probability? Well, here's an example. Suppose that 86% of the total hospital visits include emergency room or operating room charges, and 32% do not include emergency room charges. If the occurrence of emergency room charges is independent of the occurrence of operating room charges, what's the probability a hospital visit includes operating room charges? So it appears we have two events. A hospital visit includes emergency room charge, we'll call that E, and an operating room charge, we'll call that R. While we don't have an explicit conditional probability, the reference to the independence of the events means that there is a conditional probability. We'll use E as the row labels and R as the column labels, and again we'll use 10,000 visits. Now, since 86% of visits include either emergency room or operating room charges, this means that 14% include neither. So of our 10,000 visits, 1,400 do not include emergency room charges and do not include operating room charges. And so those 1,400 are going to be in this box. Since 32% do not include emergency room charges, then the total of the non-emergencies should be 32% of 10,000, that's 3,200. And since we've located 1,400 of them, that means the remaining 1,800 will be including operating room charges. Also, since 3,200 did not include emergency room charges, then the remaining 6,800 visits will include emergency room charges. Now, we don't know how the emergency room visits are distributed between the operating room and non-operating room visits. But we know that they are independent, which means the conditional and the unconditional probabilities are going to be the same. So note that at this point we have this second row completely filled out, and that means we can describe any probability out of this total, the non-emergency room charges. So we can find the probability of R given not E. Well, that's 1,800 out of 3,200. And since the events are independent, this is also the probability of R. And so that means this fraction out of 10,000, 5625, will actually have operating room charges, and the remaining will not. Finally, since there are 5,625 hospital stays with operating room charges, and 1,800 of them do not involve emergency room charges, that means the remaining 3,825 do. And again, we can complete that second column as well because we know the total number of visits that do not include operating room charges. And so we find that 2,975 do have emergency room charges. Now we want the probability a hospital visit includes an operating room charge. And we see that 5625 of the hospital visits do include an operating room charge, and so that will give us our probability.